Hello, Zahir here. In today's video, we are going to learn how to diagonalize a 2 by 2 matrix, a very important concept in linear algebra. You will often see this used in engineering problems, especially in control systems and vibration analysis in mechanical department. Diagonalization helps simply complex matrix computations. And trust me, it makes your life a lot easier when solving systems. I'll guide you through everything step by step. So don't worry if this is your first time. Let's get started. Diagonalization of a 2 by 2 matrix. Okay, right. Welcome to Dr. Zahir Math. Okay. So what are the steps you need to follow? It's just an extension of eigenvalues and eigenvectors. Just keep in your mind. So what are the steps you're going to follow here? Right. Step number 1. Find eigenvalues, which is same what we studied before in that. Number 2, find eigenvectors. Step number 2, eigenvectors. These two steps already you studied in the previous videos. Finding eigenvalues and eigenvectors of a 2 by 2 matrix. If you have not watched that video, please go back to the videos. Module 3 and 3 by 3 eigenvalues, 2 by 2 eigenvalues I put it. Just choose it, 2 by 2 eigenvalues. Okay, right. Then number 3, you are going to create a model matrix. What is the matrix name? Model matrix. You're going to create the model matrix P. I'm going to call it as a name with the help of eigenvalues. Eigenvectors. With the help of eigenvectors. Keep in your mind, with the help of eigenvectors. Step number 4, you are going to find P inverse. 100% you can find P inverse using calculator in this. But if a question is find A inverse as a separate question, you are not supposed to use calculator. You have to do by steps. But here already we are finding eigenvalues, eigenvectors, and in this case we are going to find out P inverse, right? And here you can use directly calculator to find P inverse. So P we created in step number 3. Step number 4 is P inverse. Step number 5, we are going to find out P inverse AP, right? This is the operation you are going to do it. You are going to get the diagonal matrix. This is the diagonal matrix or diagonalized matrix. What type of answer you will get, keep in your mind. If it's a 2 by 2 matrix, okay, right? You will get lambda 1 here and lambda 2 here, and here you will get 0 and 0. So this is the final answer, you have to get it. Keep in your mind. Once again, I'll repeat. Step number 1, find eigenvalues. Step number 2, find eigenvectors. Step number 3, create a matrix with the help of eigenvectors. Let me tell you what is that. Suppose your first eigenvector is, for example, 1 and 3. Suppose your second eigenvector is, for example, 5 and 0, for example. So what will be your P matrix means? It is 1, 3 and 5, 0. That's what. This is what you're going to see. So this is called model matrix. Okay. Create a model matrix P with the help of what? Eigenvectors. So this is your P. It's easy or not? Yes. Then you're going to find P inverse using calculator. Then you're going to find out P inverse multiply A matrix multiply and P. This one I'll tell you 100% you can use calculator to get this diagonalized matrix. No need to do step by step. Okay, right. I'll teach you end of the session. I'll teach you how to find this one in the calculator directly. Right. Let's go to the question. First question, 2 by 2 matrix. Only one question, I'm going to do it. Diagonalize the matrix. What is step number 1? Step number 1, we are going to find out eigenvalues. What is step number 1? We are going to find eigenvalues. It's a 2 by 2 matrix, right? So what will be your characteristic equation? Your characteristic equation is lambda square minus beta 1 lambda plus beta 2 is equal to 0. What is your beta 1? Beta 1 is equal to sum of leading diagonal elements. Sum of leading diagonal elements. So what is leading diagonal elements? This is your leading diagonal 4 and 3. So this is going to become 4 plus 3, which is equal to 7. So this is your beta 1. Next, we are going to calculate beta 2. What's your beta 2? Beta 2 is determinant of A. It's a 2 by 2 matrix, so no need to go to the calculator and wasting the time, but you can check your answers whether it's correct or not. 4 times 3, right? And then minus, 4 times 3, again 4 is not correct. 4 times 3 minus, we are going to make 2 times 1. So 2 times 1, 4 into 3 is 12. 12 minus 2, it's going to become what? 10, right? So beta 2 is equal to 10, right? And beta 1 is equal to 7. So what will be your characteristic equation? Your characteristic equation is lambda square minus beta 1 lambda plus beta 2 is equal to 0. So lambda square minus your beta 1 is what? 7. Lambda plus beta 2 is equal to what? 10. Now you need to go to mode 5 and then 3. Let me take the calculator, right? So mode 5 and then 3, let's go with that 1, right? Minus 7, right? And then 10. So equals. You're going to get 5 and 2. So lambda is equal to 5 and, lambda is equal to 5 and lambda is equal to 2. So this is your eigenvalue, right? So next you're going to get eigenvector, right? So step number 2, you're going to get eigenvector. Step number 2 is what? You're going to get eigenvector, right? So step number 2, you are going to find eigenvector, right? Eigenvector. Yes, what is the formula? So you're going to find matrix A minus lambda I times x is equal to what? 0. So I told you the changes will occur only in the diagonal elements. So here you will get 4 minus lambda. Here you will get 3 minus lambda. Because your matrix is what? 4, 1 and 2 and 3. This is your matrix. Okay. So 4 minus lambda, 3 minus lambda. And here it is 1, here it is 2, right? Operating on x1, x2 is a column vector. And this is 0, 0, right? Yes. Okay. Now this is going to become your equation 1. Every time I used to call this as equation number 1. And we are going to do 2 cases, right? Case 1 we are going to do. What is your case 1? Your case 1 will be, right? Lambda is equal to what? Lambda is equal to the first one 5. So lambda is equal to 5. When lambda is equal to 5, what is your answer? The first matrix will be 4 minus 5, which is equal to, well, let me write 4 minus 5 and 1, 2 and 3 minus 5 times x1, x2 operating on 0, 0, 0 equals 0, right? Operating on x1, x2. 4 minus 5 is minus 1, 1, 2 and 3 minus 5 is going to become what? 2. So operating on x1, x2 is equal to 0, 0. I told you most of the time in 2 by 2 matrix, always you will get what? Identical equations, and I ask you to take the first equation only. So first row, first column. So it will be minus x1 plus x2 is equal to 0. I told you always to find x1. So minus x1 is equal to minus x2. If you cancel this minus, you will get x1 is equal to x2. Same situation we come across in the last video also. So what will be your first eigenvector? If I choose x2 is equal to 1, what will be x1? It is also 1. Why? Because x1 is equal to what? x2. So we got the first eigenvector. Let's go and find the second eigenvector. In case 2, what is that? Lambda is equal to 5 and lambda is equal to what? 2. So put lambda is equal to 5 in equation 1. Put lambda is equal to 2 in equation 1. Okay, right. When I put lambda is equal to 2, look here. 4 minus 2 is 2 and then 1, 2. 3 minus 2 is what? 1. Operating on x1, x2 is equal to 0, 0, right. So now first row, first column, which is 2x1 plus x2 is equal to 0. If you do the second also, same equation. So no need to do. What I said, find x1. So 2x1 is equal to what? You're going to find out is equal to minus x2. So when you divide by 2, x1 is equal to what? Minus x2 divided by 2. Minus x2 divided by what? 2, right? Or you can say that x2, x1 is equal to minus x2. Whatever it is, you can do like that. Okay, so what type of values you are going to choose it? For example, suppose if I choose x2 is equal to 2, for example, or minus 2, for example. So for example, choose, right, x2 is equal to, don't give fractional values because when you're operating the calculator, you will make mistakes. Try to avoid careless fractional values. Okay, so suppose if I choose x2 is equal to 2, for example. Okay, what will be your x1? X1 will be minus 2 divided by 2. 2 gets cancels. So you're going to get what? Minus 1, right? So your vector will be, capital X2 will be, I choose x1 is equal, I choose x2 is equal to 2 and I got x1 is equal to minus 1. Okay, again I'll repeat, listen carefully. So this is the equation, you got it, okay? Yeah. So 2x1, I choose this x2, I took it the other side, okay, because 2, 1, 1, 2. So 2x1 plus x2 is equal to 0, right? So what I will get 2x1 is minus x2. Then I divide. So x1 is equal to what? Minus x2 divided by 2, right? Because this 2 gets cancels, okay. Suppose I choose x2 is equal to, x2 is equal to 2. For example, if I choose, I put 2 here, right? So what happens? This 2 and 2 gets cancels. So I'll get x1 is equal to what? Minus 1. Is this the only value I have to choose, teacher? Not necessary. You can choose any type of value, any numbers you can choose. But if you avoid fractional values, you will try to avoid mistakes in the calculator. Sorry, okay, right. So can I choose x2 is equal to minus 2, teacher, to get 1? Already you have 1 vector is there. So don't take identical values, okay. Try to give other unknown vector, okay, right. So this is your x2, so which is equal to what? Minus 1 and 2. So we got the eigenvectors x1 and x2. What is step number 3? Let me go again. So step number 3 is you are going to calculate or create, you are going to create a model matrix P with the help of eigenvectors, right? Yes, so let me create a model matrix, which is step number 3, right? So step number 3 is I'm going to create a model matrix, okay? So model matrix P, right? P is equal to, with the help of eigenvectors, or with eigenvectors. You can say whatever the words you want, you can use it. With the help of eigenvectors. So what is your eigenvector? First vector 1, 1. Let me take 1, 1. And the second eigenvector minus 1, 2. You should write on the same positions. Teacher, can I write 1, 1 in the row wise? Can I write the second one row wise? No. Always this is also column wise, and this is also what? This is also column wise. Okay, keep in your mind, right? So therefore 1, 1 minus 1, 2, right? So now step number 4 is you're going to find P inverse. P inverse I can find out now itself, because 1 by determinant A, and then you have to position change. But anyway, I'll teach you in the calculator how to find P inverse in the calculator, right? So already if you want P inverse how to find manually, you can go to the video. Already I just did one video for how to find inverse of a 2 by 2 matrix. And how to find the inverse of a 3 by 3 matrix, okay. Shift 9, 3, I restarted that. Then I'll go for mode, matrix number 6, and then number 1, mode, okay, 6, and then 1, and then you go for 5. 5 is a 2 by 2 matrix, okay. Give the input 1, minus 1, and then 1, and then 2, right, and then AC. Shift 4, choose mat A. Shift 4, choose mat A, which is number 3. Okay, number 3, and then open a bracket here and just make a mat A like this. So just you put the brackets, because mat A is already there. Put the brackets and move the cursor to the end. Then after finishing this one, press the button, this inverse. What's the button? X inverse. This is the button in the calculator. Okay, in the first row. Here is a calc, and here is the integral symbol. If you go same here, this X inverse is there. So you press A inverse, okay, inverse, and press equal. You will get 2 over 3, right? Next is 1 over 3, okay, and the next is minus 1 over 3, minus 1 over 3, and the next is 1 over 3. Okay, right. So now we are going to use the step number 5. So step number 5 is very simple, right? Step number 5 is, what did I say? P inverse AP is equal to, you have to get the diagonal matrix. What is your P inverse? Just now we calculated 2 by 3, okay, 1 by 3, right? Minus 1 by 3, okay, and then 1 by 3. This is your P inverse. And the A matrix, this is your P inverse. And your A matrix is your question, which is your 4, 1, 2, 3. This is the question given in the exam question. And the next is P matrix. P matrix just now we created with the help of eigenvectors 1, minus 1, 1, minus 1, and then 1, 2, right? So how to do this in the calculator? Let me tell you. Restart your calculator, shift 9, 3, okay, right. So this is your mat A, okay, times multiply. This is your mat B. This is the command you are going to give it in the calculator. And this is your mat C, okay. This is your mat A, right. Let me start mode and then 5. Sorry, no, sorry. Mode and then 6. Mode 6, 1. And press 5. So let me start here. Mode, okay, 6 and then 5, okay. So if you press 5, you ought to give A, that is mat A, okay. So A matrix you will have to give, which is 2 divided by 3 and then 1 divided by 3 and then minus 1 divided by 3 and then 1 divided by 3, okay, just given mat A. So press AC, okay, press what? AC, this finish. Next again mode 6, again mode 6, mode 6, okay. Then now press 2, mode 6 press 1, this is mode 6 press 1 and then 5. Mode 6 press 2, okay, press 2, right, press 2, that is mat B, okay. B is equal to and then 5, this is 5, okay, and then 5, 2 by 2 matrix, give this matrix B, okay. 4 press equal, 1 press equal, 2 press equal, 3 press equal. So this is your mat B, okay. Then AC, press AC, right. So finished. Again mode 6, okay, mode 6, right, and then press number 3, press number 3, that is your mode C, then 5. So now it will be C matrix, okay. So press the C matrix, which is your this matrix C, right, okay. So press number 5 and then 1 press equal, minus 1 press equal, 1 press equal, 2 press equal, press AC. So then press AC, okay. After that, right, now bring it to the screen, right. Now shift 4, what you're going to do, shift 4. So shift 4, right. Now you press number 3, okay, right, and then press multiply. So the screen will be mat A now, okay. Screen will be mat A, multiply. So press multiply, again shift 4, again shift 4, right. Now press number 4. So if you press number 4, now the screen will be mat A times mat B will come, okay, right. Again you press multiply, right. Again you press shift 4, right. Then again shift 4 and press number 5. Press number 5, you will get mat A times mat B times multiply, you will get mat C, okay, right. Now press equal. If you press equal, you will get the answer, very nice answer, which I told you. Matrix, you will get the first number is 5, right, and then you will get 0, then you will get 0, and then you will get 2. What a lovely thing, right? This is your what? Lambda 1, and this is your what? Your lambda 2. So that we diagonalize the matrix, okay, diagonalize the 2 by 2 matrix. Keep matrix, right, sorry, matrix, right. So this is what I told you in the procedure, right? See here, when I see the 5 steps I gave you, right, in the 5th step I gave you, your final answer will be in what? So your lambda 1, lambda 2 will be here. So that's what I told you, right, when I was writing this one. So in this way, just keep in your mind, your final answer, the diagonal elements must be your eigenvalues, must be eigenvalues, must be. Keep in your mind, your diagonal values must be your eigenvalues. In this way, you're going to do what? Diagonalization procedure. Okay, right. So well done. You have just learned how to diagonalize a 2 by 2 matrix. A powerful tool for simplifying matrix operation. Once again, I'm telling, this is a powerful tool for simplifying matrix operations. Keep practicing, and in the next video, we will look at how diagonalization works for a 3 by 3 matrix. Don't forget to like, share, and subscribe for more helpful videos. See you. Take care. Bye bye.